Oh,
All
well,
right. Well, I'm ready if you are, Daniel. And get started.
yep.
Or you
I'm
think
ready
we
when
had
you
a...
are.
All right. So first of all, my name is Wyatt Studer, and I'm a university ambassador at SWE Foundation. And today I'm just talking about SWE and how it's decentralizing the internet with Walrus. And I've got Daniel Levitt here with me, who is. I'll let him introduce himself.
Hey everyone, I'm Daniel. I'm one of the DevRel engineers at the SWE Foundation. In a little bit, I'll be covering some of the bounty information as well as demoing off some existing projects on SWE, but I'll let Wyatt kick it off here.
All right, we'll get started. So first off, we'll talk about SWE's superpowers. And so the three big superpowers of SWE is, of course, the object model, move, and the PTBs. So with the object model, it's just a much more secure method of handling Web3 assets. And of course, move is the native smart contract language with object-centric programming in mind. And our PTBs are programmable transaction blocks. These allow all types of builders to interact with SWE's object-centric model without having to have just a whole bunch of smart contract know-how. It just makes it a lot more easy for developers to get started. So continuing on our SWE's object model, everything is an object. Smart contracts. So smart contracts are objects, and they're called SWE move packages. And these are used to manipulate objects on the SWE network. We also have our global resources like liquidity pools, marketplaces, metadata, and all other public goods and resources can be represented as shared objects. So these objects can be mutable or immutable and can be accessible by everyone on the network. And so even owned assets, coins, NFTs, and all other assets are objects that are owned by individual accounts or other objects if they're nested. And an owned object is accessible only by its owner. And this is for parallel transaction execution. So continuing on, object ownership. Object ownership on SWE is just like physical objects. This makes it easy to understand and interoperable. So for instance, a coin. Coin behaves like cash. So where each bill has a US dollar value, each coin on SWE has a SWE value. So just like I could give you a 10, a 5, a $1 bill, and they have these different numeric values, you can do the same on SWE, where you could hand people these different coin objects that have their own denominations of SWE value. Or even like a car. Like, let's say your friend wants to borrow your Lamborghini. Well, he'll need the keys, of course, to drive it, and he's going to know where the garage it's stored at is located. So, much like this, a co-founder, if you have one on your project, would need an object to allow him admin controls, and he would need to know the location of the smart contract in order to change the protocol. So moving forward on to like SWE's take on assets, we're going to look at like a token example here. So on many other contracts, the way that they are changed, the way that they do this is they'll use a ledger system. And for instance, so if Alice wanted to purchase a token on these ledger systems, what she would do is she would purchase a token, and then the smart contract would mark on their ledger that Alice now has one token. And then if she wanted to send that token to Bob, she would then the smart contract would then remove that token from Alice and then add it to Bob's in the ledger. Now, this poses just already a great security risk in the sense that if the smart contract was written incorrectly or if Alice was a bad actor, you could possibly have accounts where Alice doesn't get this token removed and Bob still gets it, essentially duplicating that coin, or where even the coin is removed from Alice on the ledger and not given to Bob, essentially destroying that, which is horrible for your tokenomics. So SWE takes a different approach at this. What they use for just this same example, but on SWE's take for it, is if you have the smart contract for tokenets and Alice wants to purchase one of these tokens, that token then creates an object on chain called tokenets here, and it's signified by this T with the square, and then gives that object, moves it directly to Alice's account where she now has possession over it. And so, well, let's say Alice wants to send that token to Bob. Well, unlike on the ledger system where you have to make use of the smart contract to do so, with SWE, that can be done independent of the smart contract. And once you send the object, it then leaves Alice's ownership and is now under Bob account's ownership. And so doing this just provides that same security um, provides the security protection that that ledger system doesn't, where Alice can't now send this token again because it is no longer under her ownership. It's under Bob's ownership. So the transfer just wouldn't go through because it would know that that was not under her account. So moving to Move, Move is the native smart contract language with an object-centric approach to Web3. It's an API layer which allows utilization of SWI's object model. So what this allows us to do with assets and ownership are being encoded in linear types. So for instance, with the function, you could say, if you give me a coin, I'll give you a car title. So this is represented by this function by, where the coin C is then moved to the function and is no longer in ownership of the account that moved it there. And the function is free to do with that whatever it needs to. And then this function will return and move a car title to that account's ownership. And so essentially you can also build upon that where if you show me your car or show me your title and pay a fee, I will give you a car registration. Now, with this example, we are taking an immutable reference that's this and car title here. So this isn't being moved into the function. This stays under the possession of the account interacting with it. And we only need to ensure that that account has it. Whereas the fee, the coin, that is getting moved into the function and removed from that original account to allow this to go through. And in return, that account that interacted with this is going to get a car registration that will now be under its ownership. So type system prevents misuses of assets. Move is designed to prevent common pitfalls. And here's three examples, which are just duplication, double spending, and destruction. It protects against duplication by not allowing just the duplication of a coin. If you had this coin passed into or moved and given ownership into function F, it won't allow you to create a copy of that in any way, whether that be just actually creating a copy or even trying to reference and then dereference that. It prevents double spending. Once that coin gets moved to the function and then moved out of the function, it cannot be moved out again because that coin no longer is owned by that function. And then destruction, same thing, is that the move language does not allow for the destruction of coins by default within these functions, whereas you can't set C equal to something because you would be destroying that value. And same with return, it would be trapped in that function and thus destroyed. So this ensures that the digital assets behave like physical ones. Then the other superpower of SWI is our programmable transaction blocks, or our PTBs. And these are client-side execution layer, and it allows for an intuitive and easy interaction with different objects on chain, and it can be built using the SWI command line interface or Rust TypeScript SDKs. And so it's a programming framework that leverages the object-oriented approach of SWI to enhance the SWI developer experience and empower SWI developers. So the benefits of PTBs, transactions on SWIs are groups of operations that act as one transaction. So it's cost effective. A single PTB can execute up to 1,024 operations, and that's huge because this greatly reduces the cost of gas way more than competitors. And it's composable. PTBs are atomic. If one operation fails, then the whole transaction does too. It's intuitive. PTBs provide an easy to grasp framework for creating, organizing, and manipulating SWI objects. SDKs for this are in TypeScript and Rust, and this allows for easy adoption without that same having to have a bunch of smart contract knowledge. It just makes it a lot more streamlined to pick up for our developers. Speaking of streamlined too, we'll get into ZK login, which is the key to mass adoption. And this allows for the end user to interact with SWI while removing the necessity for remembering mnemonics and seed phrases, and by being able to log in with their existing social network accounts. And so building off of that, even mnemonics and keys, they're just not going to get us mass adoption. Complexity is the killer of adoption, and the ultimate killer DApp for blockchain is accessibility. I mean, how many people do you know, just even in Web 2, when they're signing up for a new program or they download an app that needs them to create an account, would rather just connect their Google account or their Facebook or their Microsoft, as a lot of applications will let you do, instead of creating a new username and password and having to keep up with another one of those. So it's just a lot more feasible in the sense of getting new users, especially those who aren't tech savvy to onboard. And so this is just an example you may have all seen, or if you haven't, of just an example of a seed phrase, what you have to use in order to access your wallet. And so expecting non-technical people to make use of this, and especially make use of it often, it's not feasible. And even if it is, they most likely wouldn't want to use it as compared to being able to simply connect a Google, Microsoft, Facebook, whatever social account to interact with smart contracts. So this native ZK login, our OAuth and zero knowledge proof, it's just one less password, and it's a gateway to seamless adoption of Web3 experiences. And so this will allow people, same way, to use just the Gmail, Ads Meta, etc. And we do have a video that kind of goes over these benefits there. And then I guess Daniel, let me know if the stream doesn't go through so well on the video side, and I can try and fix it. Go. And so lastly, we'd like to introduce Walrus. Um, Walrus, it's a decentralized media storage and data. So we're talking videos, images, PDF, etc., all decentralized. And so with building the critical infrastructure to enable a more decentralized internet, Miston Labs built SWE as its first foundation structure capable of having the fastest consensus, frictionless developer experience, unbounded composability with objects and PTBs, and best building blocks for modern user experience. And so now it's tackling decentralized storage. So as you have it, if you have like an NFT on chain, the photo that smart contract is attached to or represents isn't stored on Web3 or decentralized. It's all on Web2. And so that's just one of the things that Walrus is trying to tackle or is tackling. And so it'll also allows for storage of long form texts, images, videos, application data, and archives. And so it's just touching up on this global data layer, which just allows the user to have gigabytes at reasonable cost, high resiliency, high performance, and programmable. It's programmable and composable, which we'll talk about on the next slide. So the Walrus overview, it's just a new delegated proof of stake decentralized storage network. It's reliably yours. It allows you to access your data even during a zombie apocalypse. It's extremely cost efficient with its two-dimensional encoding for data with constant overhead of just 4 to 5 times. That means that even if you had hundreds or thousands of nodes, they're only going to get replicated 5 times as opposed to thousands of times. It's also extremely scalable. Each new node added increases the read and write throughput as opposed to slowing it down like other chains. It's resilient. It can write with a third of the nodes failing and read with two-thirds of them failing. And it's programmable. These smart contracts, you can make them to buy double capacity at a certain date. So you could buy double capacity at like March 3rd, 2035 or September 5th, 2026. Just anything you want. You can even make it as specific as, sell at a discount when there's a full moon in Japan, which is amazing. And so the attestation too is it's just a delegated proof of stake, and on top of that, there's a Miston Labs new invented attestation challenge, and this is where the nodes will challenge each other to prove that the data is always secure. And so if you'd want to learn more about Walrus, you can always check out their site at walrus.xyz, or the QR code there leads to their white papers. And I believe we have a couple demos too and examples of both ZK login and Walrus well, I'll just let Daniel get to the demos.
Yeah, thanks, Wyatt. Let me share my screen real quick
PTBs.
here. All right, let's see. All righty. Okay, thanks, Wyatt. Yeah, so Wyatt was able to give you guys like an overview of SWE and all of the different aspects of the developer experience, the user experience, and I just wanted to hammer home some of those points by showing you some live demos of apps that we see on SWE today. And the first one's going to be showing you an example of how PTBs are changing the landscape of dApps that we see. So I'm going to navigate to this page here. Can you guys see this website all right?
I can. Yep.
Yeah. Okay, sweet. So this is what this is. This is a DEX aggregator. So this will, when you want to perform a swap, it will aggregate all of the DEXs that are on SWE and find the most optimal route for you to get the least amount of slippage. And it's doing this all on the client side. So let's say I have one ETH and I want to swap it to SWI. It's going to show me the swap it's going to perform. It's going to split the ETH into 6 different trades. And then each of the paths is a chain of swaps that are all happening on different dexes or order books. And the important thing to note that if I were to connect my wallet and execute this trade, it would happen atomically on chain. And I don't know if for any of you who are familiar with like Solidity development, when you're interacting with different protocols, but you want to do it atomically, this would require some sort of wrapper smart contract function. But on Sui, there's no need for that. You can do this all on the client side. So if I were to execute this, it would be automatically executed on the client side and be executed in an atomic manner. So if any of these trades didn't go through, the whole transaction would fail. So this is just one example of like how PTBs can enhance the developer experience and lead to better users, better apps. And then we have this example app to show ZK login. So I'm going to give you all a moment to scan this QR code. You can scan it on your phone, and you'll see how easy it is for users to use Sui apps. So this is as easy as it will be for us and everyone else to be able to use the apps that you make at the end of this hackathon. So I'll give you guys another moment to scan these, and then I'll navigate to this page myself. Okay. So what this is just an example app where we allow the user to sign in with Google rather than connect their own wallet. So that way you can do this on mobile or any random laptop that you have. So I'm going to connect with my Gmail account. This is something a new user would already have, so they don't have to set anything up. And then we have this counter. This counter is actually a deployed object on Sui, and I can go ahead and click increment. You should see it go through. There we go. So this count, like it just went from 338 to 339. And if you guys go on this, you actually can see this in real time as well. So this is just an example. And note that this Sui address was created for me behind the scenes, but it doesn't have any Sui in it for gas. So all of these transactions that I'm executing are all happening gasless as well. So this is another experience experience enhancing effect that we have on Sui. Okay, and then I also wanted to mention, just because I had a quick question from one of you guys, SWE is having an annual global hackathon that's going on right now. And anything that you guys build in this hackathon for the N3XUS Hackathon can be also applied to the Overflow Hackathon as well. So you can kind of get some double dipping there as well. Cool. And I'm going to give it back to Wyatt to talk about some POAP opportunities. Wyatt, if you'd like, I can just flip to the next slide
Yeah,
and
that
you can,
works.
okay.
Yeah. So for those of you competing in the sweepstakes challenge, and if you're not, I highly recommend it. It is very accomplishable. Just by attending workshops, you can earn enough XP to enter into sweepstakes for um, prize money. And this can be done by a plethora of ways, but one of the ways here is by minting the Poe app. Whether or not you're already hooked into Web3, you can scan this. If you already have a wallet, great, you can go ahead and mint it. If not, you can reserve it with your email, and we'll be publishing a video later this evening on how to create and connect a wallet to Poe app to be able to earn the XP for that quest. And if you wanted to get hooked up to the Zlee, even if you don't want to start it yet, you can hop on there and just see what all types of quests we have already. We're posting them weekly, and there's just a bunch of stuff. Just by being active, you'll earn an entry into our sweepstakes to get you some prize. Oh, and I'll turn it over to Esvin. I believe he had some closing remarks.
No, no. First, real quick, do y'all want to run it down through how exactly the Sui bounty looks like, the structure, the weeks, and all that?
Yeah, I can talk about that. So let me get to, so You guys will be able to find this SWE track for the Nexus Hackathon on the Nexus dashboard on the SWE bounty. But the way it works is because this is such a long hackathon, we didn't want to throw you in the deep end, especially if this is your first time building on SWE or maybe even building on the blockchain in general. So we designed weekly challenges. So there's a challenge 0, which is just getting started on SWE. But then every week we'll have you focus on a certain aspect on SWE. Like let's say making your first NFT collection with smart contracts and then using PTBs to start minting these NFTs. You'll learn how to create your own coin. And then some of the challenges aren't published yet. Those will be published as the hackathon progresses. So for example, you'll be able to open up the challenge that you want to look at. You can read the instructions and then look at the resources we provide for you, and then just make sure you turn in these deliverables. Yeah, and then at the end of the challenge, we have 7 challenges plus the initial challenge. And after that, you'll have a chance to use the next few weeks after that to do a free build. And this is where you'll take everything you've learned over the last 7 or 8 weeks and show us what you got and build whatever you want on top of SWE. So this is your chance to um, build your new ideas and make it a next generation app on SWE. And the way the pricing will work is that for everyone that completes all of the challenges, you will be entered into a raffle where you can win $200, and that's up to 35 of you. So if there's less than 35 of you, then you all will automatically win that raffle. And if there's more, then it will be randomly selected. And then I believe for the free build, we will give $1,000 to each of the top teams, the 3 top teams that we decide on. Yeah, and then there's some other requirements for the submissions that you can read about on this page as well. And at this point, I'd love to take the time to answer any questions that you have for me or Wyatt, either about SWE, about developing on SWE, or any questions about the bounty as well. Great, no questions. Okay, that means we covered it all.
I'll throw a question out there.
Yeah, sure.
What are the best places to go for the resources? I know one of our partners for the hackathon, HackQuest, has some good things and resources that they can use for beginners. But aside from that, what other good stuff is there?
Yeah, so if you go under each challenge, we have hand-picked resources for that specific challenge and the subject that you're going to be learning about. Like let's say the NFTs, we have a specific NFT guide that you can follow to complete that challenge. And if at any point you have any developer questions or are looking for more resources or just want to ask general questions about SWE, there's the SWE channel in the Telegram chat for this hackathon so that you can use to find me as well as my other coworkers that we can answer your questions and direct you to any resource you'd like to find.
Did anybody need another chance to see the POAP QR code as well? Okay. Well, if that's everything for me and Daniel, if you didn't have anything else, and as if y'all are done too, and I guess last question, if there's no questions, then we guess go ahead and close off this workshop.
Awesome. Thanks, Wyatt. Yeah, I am really excited to see what you guys build, and I hope you guys build on SWE. And if you need any help, just message me in the Telegram.
All right.
Awesome. All right. See you guys. Thank you.